everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable questions. So let's get going. Problem solve x square d square minus xd minus 3 into y equals to x square log x. So here we are given a differential equation with variable questions. Now we are going to reduce this to a differential equation with constant questions by making some substitution. And also this is we are given a Cauchy's equation. Given Cauchy's equation x square t square minus xd minus 3 into y equal to x square log x. Now let's make the substitution. Put x equals to e power z, then log x to the base equals to z for x greater than 0. Let theta equals to dy dz. Here theta is a differential operator with independent variable z. Then xd equals to theta and x square d square equals to theta of theta minus 1. Now the above equation becomes theta of theta minus 1, replace x square d square by theta of theta minus 1 minus replace xd by theta minus 3 into y equal to x square, replace x by e power z, then you'll get e power z whole square log x, replace log x by z. This becomes theta square minus theta minus 3 into y equal to z into e power z whole square is e power 2z. Right? Now, the above equation becomes theta square minus theta is minus 2 theta minus 3 into y equal to z into e power 2z. Now, we have reduced the given differential equation to a differential equation with constant coefficients, right? And also, this is in operator form, which is in operator form. F of theta into y equals to some function of z, right? F of theta into y equals to some function of z, where f of theta equals to theta square minus 2 theta minus 3. Theta square minus 2 theta minus 3. Now we need to find the general solution to the given equation, which is given by y equal to yc plus yp. Let's now find yc using the auxiliary equation and later we'll go for yp. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of theta square minus 2 theta minus 3. Let's replace differential operator theta by m, so that we'll get f of m equals to m square minus 2m minus 3. Now our auxiliary equation becomes m square minus 2m minus 3 equals to 0, right? Let's write minus 2m as minus 3m plus m, right? Minus 3m plus m is minus 2m minus 3 equals to 0. Now take m common from the first two terms, you'll get m times m minus 3 plus the next two terms remains the same. Now we are having a minus 3 in both the terms, so let's take m minus 3 common from the two terms, we'll get m minus 3 into m plus 1. Right, now equate each factor to 0. From m minus 3 equals to 0, we'll get m equals to 3. From m plus 1 equals to 0, we'll get m equals to minus 1, right? Then m equals to 3 and minus 1 are the roots of our auxiliary equation, or m equal to minus 1 and 3 are our roots of our auxiliary equation, right? Therefore, the roots are real and distinct. We know that when two roots are real and distinct, say m1 and m2 are real and distinct, then yc looks like c1 e power 1 root into z plus c2 e power another root into z, right? Now let's write our complementary function. yc equals to c1 e power 1 root minus 1 into z plus c2 e power another root 3 into z. Now complementary function becomes yc equals to c1 e power minus z plus c2 e power 3z, right? Now we need to write in terms of x because we are having yc in terms of z. Now we can replace e power z by x. So before replacing e power z by x, we'll write e power minus z as e power z power minus 1 plus c2 into write e power 3z as e power z whole cube. Now replace e power z by x. We'll get c1x inverse plus c2 x cube, right? Therefore y is equals to c1x power x inverse plus c2 x cube, or we know that x power minus n equals to 1 by x power n. Then we can write x inverse as 1 by x, right? Now we can write this as c1 by x plus c2 x cube, right? Therefore y is equals to c1 x inverse plus c2 x cube, or c1 by x plus c2 x cube. We got yc. Now let's find yp, particular integrals. We'll find yp using 1 by f of theta into q of z. This is equals to 1 by f of theta. We have f of theta and q of z, where f of theta is theta square minus 2 theta minus 3 and q of z is z into e power 2z, right? Or we can write it as 1 by theta square minus 2 theta minus 3 into e power 2z into z. See, this is of 1 by f of theta into e power az into v form. Now we'll shift e power az towards left by replacing this theta with theta plus a, and later we'll operate v with 1 by f of theta plus a, right? Now compare e power 2z with e power az. Then for a equals to 2, we'll find theta plus a, which is equals to theta plus 2. Now shift e power 2z towards left by replacing this theta with theta plus 2. We'll get theta plus 2 whole square minus 2 times theta plus 2 minus 3 into z, right? This is equals to e power 2z into 1 by, expand theta plus 2 whole square using a plus b whole square formula. We'll get theta square plus 2 square 4 plus 2 2s are 4 into theta is 4 theta minus 2 theta minus into plus minus 2 2s are 4 minus 3 into z, right? Now yp becomes e power 2z into 1 by, here my plus 4 minus 4 gets cancelled and we'll get theta square plus 4 theta minus 2 theta is plus 2 theta minus 3 into z, right? See, this is all 1 by some function of theta into z power k form, right? Now take the lowest degree term common from all the terms. If you notice, in the first two terms we don't have any minus 3. So what we'll do, we'll just multiply and divide minus 3 to the first two terms. Okay? Plus, we'll write minus 3 as plus of minus 3 for our convenience. Now take minus 3 common from these two terms. We'll get e power 2z into 1 by minus 3 into theta square plus 2 theta by minus 3 plus 1 into z. or theta square plus 2 theta by minus 3 plus 1. Or we can write it as e power 2z into 1 by minus 3 into minus of, we'll write theta square plus 2 theta by minus 3 as minus of theta square plus 2 theta by 3 plus 1 into z, right? Now this becomes e power 2z into 1 by minus 3 into, let's write term involving plus sign firstly. So we'll get 1. Now write the term involving minus sign. We'll get 1 minus of theta square plus 2 theta by 3 into z, right? Now split the fraction. We'll get e power 2z into 1 by minus 3 into 1 by 1 minus of theta square plus 2 theta by 3 into z. This equals to e power 2z into, we can write 1 by minus 3 as minus 1 by 3. And see the second fraction is of 1 by 1 minus x form. So we can write it as 1 minus x whole inverse. We can write the second term as 1 minus of theta square plus 2 theta by 3 whole inverse into z, right? Now we can write this as e power 2z into minus 1 by 3 is minus e power 2z by 3 into 1 minus of theta square plus 2 theta by 3 whole inverse into z. Now we can expand this using 1 minus x whole inverse formula, binomial series expansion. 1 plus x square plus so on. Okay. So before applying this formula to expand 1 minus this whole inverse, we'll find the derivatives of z. Theta of z is, derivative of z with respect to z is 1. Theta square of z, find theta square of z. Theta square of z can be written as theta of z is equals to theta of 1, because theta of z with respect to z is 1. Again, find derivative of a constant with respect to z, which is 0, right? Or derivative of a constant with respect to z is 0, right? Likewise, theta cube of z is 0 and so on. In general, theta per k of z is 0 for k equals to 2, 3 and so on, right? Now keeping this in mind, we'll expand this one using binomial series expansion formula. Expand 1 minus theta square plus 2 theta by 3 whole inverse, which is equals to 1 plus, for x equals to theta square plus 2 theta by 3, we'll get theta square plus 2 theta by 3 plus theta square plus 2 theta by 3 whole square plus so on, right? This equals to 1 plus theta square plus 2 theta by 3 plus theta square plus 2 theta whole square by 3 square plus so on. This equals to 1 plus 1 by 3 into theta square plus 2 theta plus 1 by 3 square is 9 into expansion of theta square plus 2 theta whole square is theta square whole square plus 2 theta whole square plus 2 into theta square into 2 theta, which is equals to theta power 4 plus 4 theta square, right? 2 square into theta square is 4 theta square plus 2 2s are 4. Theta square into theta power 1, add the powers 2 plus 1, 3, you'll get theta cube, right? Now write the expansion of theta square plus 2 theta whole square here, we'll get theta power 4 plus 4 theta square plus 4 theta cube plus so on. So, we notice that in third term, we are having all higher derivative terms, right? I mean, all the three terms are higher derivatives. So, completely from here, we'll get higher derivative terms. So we can neglect all the terms from here because it involves higher derivative terms. Theta power k of z equals to 0. Since theta power k of z is 0, for k equals to 2, 3 and so on, right? So we'll neglect all the terms from here and also theta square term. This term from the second term. Okay, we'll take 1 plus 1 by 3 into 2 theta. Fine. Now coming to yp. Yp becomes minus e power 2z by 3 into expansion of 1 minus x whole inverse is 1 plus x plus x square plus so on into z, right? This becomes minus e power 2z by 3 into 1 plus theta square plus 2 theta by 3 plus theta square plus 2 theta whole square by 3 square plus so on into z. This is equals to minus e power 2z by 3 into 1 plus 1 by 3 into theta square plus 2 theta plus 1 by 3 square is 9 into expansion of theta square plus 2 theta whole square is theta power 4 plus 4 theta square plus 4 theta cube plus so on into z. Since theta power k of z equals to 0, for k equal to 2, 3 and so on, so neglect higher derivatives theta square, theta cube and so on. So we are going to neglect all the terms from here and theta square from the second term. This is cube. Fine. Now this becomes minus e power 2z by 3 into 1 plus 1 by 3 into 2 theta into z. So we removed all the higher derivatives. Now this becomes minus e power 2z by 3 into z plus 2 by 3 into theta of z. 1 by 3 into 2 is 2 by 3 into theta of z, or we can just include one more step for our convenience, okay? 1 plus 2 by 3 into theta of z. This is equals to minus e power 2z by 3 into 1 into z plus 2 by 3 into theta of z, right? This is equals to minus e power 2z by 3 into z plus 2 by 3 into theta of z is 1. This becomes minus e power 2z by 3 into z plus 2 by 3. This is equals to minus e power 2z by 3 into, take the LCM of two terms, we'll get 3. In the numerator, we'll get 3z plus 2, right? This is equals to minus e power 2z by 3 into, split the fraction as 1 by 3 into 3z plus 2. Then yp becomes minus e power 2z into 1 is minus e power 2z by 3 3s are 9 into 3z plus 2, right? Now we are having yp in terms of z, but we need to write in terms of x. So what we'll do, we'll just replace e power z by x and z by log x. Okay. For that purpose, firstly, we'll write e power 2z as e power z whole square by 9 into 3z plus 2. Now replace e power z by x and z by log x. Then yp becomes minus x squared by 9 into 3 log x plus 2. So we got yp minus of x squared by 9 to 3 log x plus 2. See, we got yp and also yc. Now we can write the general solution. The general solution is given by y equal to yc plus yp. Okay, let's write for the two yc's. Firstly, I'll go for the first one. Y equal to yc, c1 x inverse plus c2 x cube plus yp minus of x squared by 9 into 3 log x plus 2. Now pick the second one, or y equals to c1 by x plus c2 x cube yp minus x squared by 9 into 3 log x plus 2. So this completes the problem. So we have seen a problem from higher order linear differential equation with variable coefficients in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.